We're just going to keep everything fast and focused and very useful. So we'll be talking about exception and exception handling. So as we all know, no matter how much you plan and write that perfect code, something will eventually break. So the magic is not in writing the perfect code actually, a perfect code that never fails. So the magic is how smart you are to handle your exceptions or failures so that your users will not even notice that anything went wrong. So to break this thing down for us today is Ife. I'll be handing over the mic to him, and I'm really very excited. I don't know about you. If you're excited, please react with your favorite emoji as Ife takes over. Thank you.
Um, Good evening, everyone. Can you guys hear me?
Yes, we can hear you, Ifeoluwa.
Okay. Good evening, everyone. My name is Ifeoluwa Olujobi. I'll be talking about exceptions and exception handling today. It's a very foundational. God, I'm big. Okay, I'm coming. Okay. Okay, so I'm talking about exception and exception handling today. Understand when you're just learning Java. So let me just start now. I'll share my screen. Um, okay. Okay. Yeah, I believe you guys can see my screen now. I really pray you can
Yes.
see my screen because I try my best not to say this. Can you see my screen? So,
Yes, we can see your screen, Ifeoluwa.
let me just start presenting. Okay, so like I said, today's topic on handling. I'll be going over starting from the problem to what exactly is an exception and how they are created in Java. We'll also talk about the hierarchy and or using the trials resource statement. Then we'll also talk about how we can throw exceptions explicitly on our own based on our business decisions, how we can create our own that we can throw explicitly, but sometimes what it's not what fits our business model. Then I'll talk about the best practices and the resources to start. So the problem, sometimes, sometimes we write every time we program, especially when you're a beginner, you code on the happy part. You just write code how you as the developer expect it to be. You don't think about the user, you don't think about edge cases, which learn. It's better to take things step by step. But there's sometimes when, not sometimes, there's always going to be that moment where maybe they use the wrong data, the data that he knows he's not meant to pass it, but he passes it. Maybe he knows or he doesn't know, and he passes it, or the user just wants to act funny that day. He just decides to act funny that day and just decides to like see whether your application will break or not. So When this occurs, this brings your program to an absolute stop. It crashes the program completely, and it disrupts the flow of the program. So, as I said here, sometimes we write code and we expect them to always run as intended. We assume users will follow the normal path we designs. They'll enter correct data, click the right buttons, and avoid unnecessary what-if moments. Suddenly, customer support calls you, our program is not working. It's showing something like null pointer exception or something like that. Now the application has crashed, the user is stuck, and you're being asked to explain what went wrong. Welcome to the world of exceptions. Exception, which is also known as exception events. Yeah. Exception is an error which occurs during the execution of a program and disrupts the normal flow of the program to instruction. Like I said earlier, it occurs when during the runtime process of your program. That's basically when your program is running, and it just brings, if not handled, it can bring the program to an absolute stop. It can completely crash your program. Now, how are exceptions created? When an error occurs in your within a method that is in a class, as we all know, in Java, the method has to be in a class. That method creates an object, which is called an exception object, hands it up to the runtime system. We know it as, it's a process known as throwing an exception. This exception object contains information about the error, the type, and the state of the program where it occurred. The runtime system searches in reverse order the list of methods in the call stack for an appropriate exception handler. So basically what it's saying is the normal order is of the way the methods were called is 1, 2, 3. If the exception occurred at 3, the runtime system goes in reverse order. That's 3, 2, 1 to search for an appropriate exception handler to handle this exception for us. An exception handler is considered appropriate if the type of exception thrown matches the type of exception. If the type of exception thrown matches the type of exception that can be handled by the handler. If the runtime system searches all methods in the call stack and no handler is found, the thread in which the error occurred is terminated. If it is the main thread, the runtime system and the program itself is terminated. So yeah, this is a little diagram showing the call stack, the method that we called. So the first picture shows the main method and your main method calls another method, which is clearly written the method with an exception handler, and it calls the third method without an exception handler, and it calls the last method where the error occurred. Now, this method here throws the exception and hands it up to the runtime system. The runtime system in reverse order is looking for the exception handler in this method that called this very method where the error occurred. No appropriate exception handler was found, and it forwarded the exception again to the next exception handler that called it exception. So the next method, that called this method. I hope you can see my cursor just for, yeah, call this method over here. So this method contained an appropriate exception handler and was able to catch the exception and recover the program. Now, I don't want to show a simple program. I was just a basic program I wrote. Fundamental. Let me close all this first. So, a fundamental. This is a simple division calculator I just made. So as you can see here, the program is basically taking two numbers where it enters a number and the user enters another number and it does the division for you, and at the end it says thank you for using our application. So now let's run it. Like you said, if you look at the normal flow of the program, it says enter a number. So I enter 3, enter another number, yeah, enter 2, and it does the division for us. Thank you for using our application. Exactly like I said, now I'm programming for the happy part. But now let's decide, like, the user does decide to behave funny, or he um enters an input that is not a valid number. So let's say, hey, he entered, immediately the program crashed. There was no exception handler to catch this exception and recover our program, and to prevent our program going to an absolute stop. So that's the problem here. Now I've spoken about what the problem and the fundamental problem and what an exception is. Now let's look at the exception hierarchy. To handle exceptions effectively, you must first understand where they come from. At the root of the hierarchy is the throwable. And we have error and exception. If you, I'm very sure most of us here are Java developers. So from this hierarchy, we know that error and exception extend throwable. For exception has two types of exceptions under its checked and unchecked, which I'll go through later as I go forward. Runtime exception here is an unchecked exception. I will explain everything. And this IO exception, SQL exception, and more formed URL exception, they are checked exceptions. The exception hierarchy. At the top of the hierarchy is the throwable class. It is the superclass of all errors and exceptions in throwable sits at the top of the hierarchy of the exception hierarchy, and only objects are instances of throwable, or only other than instances of throwable can be thrown by the JVM, or you can throw them using the throw statement. Now, throwable per se, the JVM by a normal convention, or if you decide to throw an exception, you don't throw the throwable, the instance of a throwable class, you throw the instance of one of its subclasses that comes from exceptions. We will see further as we go. Error, they represent critical conditions that applications are not expected to handle because they indicate serious error, out of memory error. Error are basically critical conditions that, yes, you can catch error, but it basically makes no sense to. There's something serious wrong in your application, and it's just better for your application to just crash. They can fix the error, like out of memory error. A type of out of memory error is when you're performing, running. Exceptional situations that a reasonable application might want to catch. At this level, we have checked and unchecked exceptional conditions that a well-written application should anticipate and recover from. They are checked at compile time, when the compiler enforces that you handle these exceptions. All from runtime exceptions and its subclasses. Error is also an unchecked exception. But like I said, normal convention, you do not catch errors. Basically, checked exceptions are enforced by the compiler. The compiler enforces that you catch them because in Java, these are exceptions that you should anticipate and your program should always be able to recover from. And then say to tell you found not found exception as per se, as I said, the example of an exception, found not found exception. Your app is going to crash. So, sorry. For Java, checked enforces that you anticipate these exceptions. Not that it's going to happen, but you should anticipate them and you should be able to recover from them for future cases. Unchecked exceptions, also known as errors or improper use of an API, and are ignored at the time of compilation. it is generally recommended that we fix our code rather than handling them. So examples are null pointer exception, array index out of bounds exception. Unchecked, not basically, but most of the time they are programming bugs in our code. And let's say in an array, we want to access an index. Let's say we have an array of 9, basically. And let's say we want to access the element in index 11. That is not possible. We cannot access the elements at index 11 when the array size is of length 10. So an array index out of bounds exception will be exception because generally it makes no sense to try to access the index in an array that does not exist. And it shows an array index out of bounds exception. So it doesn't make any sense for you to catch that exception. The recommended approach is to go back to your code. Now that I've spoken about exception and the exception hierarchy, now I'll speak about how we can catch them and prevent our program from coming to a crash. And I'll show some coding examples. So, exception handling, try, catch, finally. Exception handler components, to try, catch, and finally blocks to write an exception handler. The try block. The try block contains the block of code that might throw an exception. The block of code that is liable to throw an exception. The catch block, you provide one or more catch blocks directly after the try block. Each catch block is an exception handler that handles the type of exception passed as an argument. You will see all this in the coding examples. The finally block always executes when resources that may have been bypassed in the try block. As for the finally block, whether an exception occurred or not, it's always going to run. We use the finally blocks to always clean up our resources, and I'll explain more about resources from the coding example. So let me just go straight to my IDE so we can move straight to. What I want to do now is to read from a file. I want to read from a file and produce the output in our code. This is basically the file that I am in my code. People, Ifeoluwa Olujobi, Nena, Timley, and Samuel Joseph. So let me start with that. So like I said, the first thing we want to do before I even show the train by checked exceptions. No. Yeah. Record reader equals to for reader. Yeah. As you can see, there's an error here, and if I highlight on that error, the compiler is already telling us unhandled exception, java.io.found exception. Like exception, and it's something that we should anticipate and we should be able to recover from. So if let's say per se, like I even complete the whole code from reading from the file and train it in my code, it's not going to compile at all because I haven't handled the do now is to put this in a try block. It's in a try block. Okay, I'll still go straight to that string. Wow. Line equals to reader the grade line, which is not equals to no. And the reason for all the errors is because they are trained. Sorry about that. They are all saying, hey, this is a check exception, and you have to anticipate them and you have to catch them before I will come. So this is basically the tribe the code that might throw an exception. We put them in the try block. The next step is inserting the catch block. Like I said, a no, exception. Now, as you can see, those red lines are gone because the compiler now know that yeah, we put a catch block that is going to handle this exception for us successfully. So, for the message, so now let's run this code. Yes, it worked. A try on catch block. As you can see, I didn't put the finally block here, but I'm just trying to show you that yes, we can use you can handle the exception without putting the finally block. Going to add the finally block right now. Like I said, the finally block or not. So I'm just going to put this here to show you that. Oh, thank you for using the application. Yeah, alright, and showing you how it says thank you for using the application as you can see here. But let's say I insert the wrong file path. Let's say I remove one letter from the file path. But this system cannot be using the application. As you can see, the finally block still run over here. Now I also said something about the finally block. Finally block in most cases is used to close our resources, whether an exception occurred or not. As you can see, a buffer reader here is a resource. So resources are basically when you perform operations like input output operation. Whole surface overview is Java basically and the operating system allocates a resource for you. So when you're done with those resources, you as a programmer, you have to close them. The operating system wouldn't close them for you. And if you forget to close them over time, it can basically, your application will basically crash. If I want to close this buffered data exception over here, I'll have to move this outside the try. Let me not do that here. I'll just say buffered data equals reader. Okay. Yeah, I did the buffered reader was first declared and initialized in the try block. But if I leave it as that, the finally block isn't going to, it's not within the scope of the finally blocks variable. That's why I have to declare it outside the try block first. So in the finally block, I say if reader is not equals to no, we what's the red line about today? Again, the close method from reader throws a checked exception again. And we also have to handle that in the try block. So, like I said before, we basically have to do another the type section. Maybe I didn't say it, but to be able to catch an exception, make sure you pass the appropriate exception type, or how will I say, the what you put as the parameter here is the type of exception you plan to catch, and that's why I'm putting IO exception and the method signature. That's my first name. Most of the time, this is what your finally block is used for, to close the resources. Close the resources that are allocated to you by the operating system. Okay. So there's one basic catch top to bottom. Once a broader exception is caught, a more specific exception below becomes unreachable. This is because the current exception type already covered its child that this will be shown in practice. So basically, we all know the whole thing of inheritance. Let me use the collection framework to explain. And then we have list. After collection, we have list, and we have array list. We know that in that hierarchy, as we go down, the specificity of each class is getting. This, if you really check this new file reader here, this new file reader throws a file not found exception. But if you check my catch block, I did not specify that I want to catch a file not found exception, or specifying I want to catch an IO exception. But on exception is a IO exception, basically. So basically what that note was saying is, if I want to catch so I can really explain what I mean. And let's say after this IO exception, I plan to catch found not found exception, which is a IO exception. Java will throw an error telling me exception, it has already been caught. This IO exception here is going to catch the found not found exception, and once it's caught, Java it is not going to go and check other exceptions to catch it. It's not going to do that. So Java will not even compile this code. It's telling me that look, found not found exception has already been caught. So a way to fix this is to make sure the more specific exception comes before the parents. Found not found exception. It's just the one in catch, yeah, identical. So let me read it again. Once a broader exception is caught, a more specific exception below becomes unreachable. So if found not found exception here came after IO exception, Java check that catch block. That's why we saw the error in the first place. And yeah, that's why we saw this error. Exception java.io found not found exception has already been caught. So yeah, let's try with resources. The try with resources is the try statement that declares one or more resource. The resource is any object that must be closed immediately the try block exits. That implements the auto top interface exclusively can be used as a resource. A try resource statement provides a cleaner syntax for handling exception and cleanup resource. Now, if you look at this, there are a lot of you can see this is a little variables and mistakes can be made, and it's a lot of stress for us to do. Basically, the first thing is you first have to declare this variable outside so that the finally block could see it. The second was to perform null check again. This is basically a boilerplate code. So basically a boilerplate code. If you want to close a resource, this was the second issue we had again. You have to perform a null. That is null. I want to access a variable that references a null object. It's going to throw a null pointer exception, obviously. So we first have to confirm if reader is not null. If reader is not null again, an IO exception, if we have to perform another try catch block. So all this is very verbose. So what the try catch block, what the try resources does for us is it gives us a guarantee that after the try block exits, whether normally or whether an exception occurs, the resources will be closed, and provides a cleaner syntax for us to handle exception objects that are auto closable. So I'll show that. Let me just auto comment this code so we can do a comparison when I'm done. For the try with resources, the first step is you are going to declare a try block. We're going to declare a try block that takes in the resources, the resource type. So buffer reader. Buffer reader is a resource because it implements the closable or auto. Is it closable or auto closable? One of them. It implements one of them, but it's a resource. So this is going to work. And like I said, the try resources will only work with objects that implement the closable or auto closable interface. Sorry, I all lazy, so I cannot start writing this thing again. Jesus Christ. I'm not writing this thing. Okay. Please. Okay. Now it's okay. Now let's run this code. It still produces the same outputs from that text file. As you can see, the try resources it provide a way cleaner syntax for us when we are dealing with objects that are resources. If you compare this to the try catch finally block, which is a whole lot of verbosity and like mistakes to be made, this is way easier to read for us. And once this try block exits, either normally or whether an exception occurs, there's already a 100% guarantee that this resource here will be closed. That's the try with resources. Now let's move on to throwing exceptions. Before we can catch an exception, something must throw it first. That exception may come from our code, from a Java library, or from the runtime environment, but regardless of where it comes from, it's always shown either explicitly by the developer or implicitly by the distributor. Sometimes we don't want to handle exception where the error occurred because the method that Now let's say I had another class here, like this class main was calling a method from another class, and that class threw an exception in that method. Now, I don't want to handle the exception in that method because I do not know calling the method I called it error, or I want to show a specific kind of error message based on the business decision. So we can decide to throw an exception further up the call stack for a method higher up the call stack to handle. Throw an exception, like we said at the beginning, exceptions can be thrown implicitly or explicitly. Implicitly in the sense that it's JVM that throws the exception. Explicitly in the sense that we can. However, this decision between explicit and implicit throwing is where the keywords throw and throws come into play. Throw is used to create and throw a single exception at a specific point. Throws is used in a method signature to declare that the method might throw certain exceptions, signaling to the caller that they need to handle or propagate them. But informing others that throwing might happen. So let's go to our code base. Like I said, yeah. Simple. Let me first remove these throws. Let me first remove it. So I have our throws example class here, which has the method read file. Like we said, we all know why these red lines are coming. Buffer reader can throw a check exception, which is IU exception, and we must handle it. What about it now? I don't want to handle the exception in this method here. I don't want to handle it here. I want the caller method to decide how to basically this for people that build packages, Java packages. It's a method that is because they can't just decide the approach to take when an exception occurs. They have to. So what do you want to do? That exception has occurred right now. Do you want to retry, or what kind of business decision do you plan to take? So, like I said, I don't want to throw this exception over here. If I put a throw here, I'm not going to specify that this method control an IO exception. Now the red lines are gone. So what this throws statement basically says is it gives the caller, it informs the caller that hey, this read file IO exception, and you must be ready to handle it. Now, throws exceptions are mandatory for checked exceptions. If let's say buffered reader was an unchecked exception, this throws will not be mandatory at all. We do not have to specify that it's going to throw an unchecked exception. In fact, the compiler will not even warn us, like we said, because the compiler doesn't enforce that we handle. Now, this main method over here. Let me just comment this try catch out first. I take comment to create file method and passing. But it's telling us that this read file here has told us that it's capable of throwing an exception, and we are not handling it. We are not handling it in the sense that it's a checked exception. Okay, like I said, if this was an unchecked exception, Java, the compiler will not warn us and we'll be able to compile our code. But it's a checked exception, and the compiler the over here. So what throws does, it throws gives you the power or the ability to make decision on the approach you want to take. Okay, you are the caller, you are the one catching the exception. What approach do you want to take? So basically, if you run this code now, it should work. Thank God. So yeah, it's working again. Shown in the next. Yeah, I will show the power of show here. Custom exceptions. Sometimes the standard exception provided by Java, like IO exception and no pointer exception. Yeah, Java provides some exceptions are basically, they are also classes in Java. IO exception and no pointer exception aren't enough to accurately describe the error conditions in your application. This is where custom exceptions come in. By creating your own exception classes, you can provide meaningful names and additional context for the errors your application might encounter. A custom exception is simply a class that extends an exception or checked exception or runtime exception for unchecked exception. Once defined, you can throw it using throw and declare it with throw like standard exception, but it carries semantics specific to application logic. So sometimes the exception that classes that Java provides for us aren't enough for our application. If we want to create business, the overall business, like sometimes it doesn't make sense to throw an IO exception for something that's not specifically input output operation, or to throw a found on. So I'm going to show this basically. Now let's look at this banking exception here. I had to prepare all this. I really wish I could like build everything from the beginning, but it's a 1 hour session, so I had to prepare all this before the whole session. So on-time exception, like we said, for you to create your own custom exception class, you can either extend runtime exception, like if you want the exception to be unchecked, or it can extend exception also for checked exception. Hi, God, my village people. It's never shown the no. Don't fix what is not broken, I beg. I was saying, and this is a constructor over here, which takes in the message you want to pass, and it calls a constructor from the throwable class, basically, which is basically. So the throwable class has four major. It has five basically, but four major constructor again. As you know, as you all know, we can overload constructors in Java. We have the public throwable again that takes only a string message. We have a public throwable that takes the string message and the throwable course. Is very useful for plain exceptions. Or throwable constructor again that the throwable course. So I don't wanted to show all this so that we will not be confused as to where this what it's calling one constructor it's from the parent class. So as you can see from throwable class, it's calling this constructor over here on the throwable class. So basically, this is let me just close all this first. Martin. And I created another insufficient font exception, which extends banking exception. As you all know, now it can extend banking exception, but the banking exception is a runtime exception. A runtime exception is basically a tradable inheritance, basically. Declared two fields here, balance and withdrawal amounts. We created the constructor here to take in the balance and the withdrawal amount, and it calls the super the constructor again in tradable class, which takes in only a string method you've seen previously before, and the argument we pass here will be assigned to this field over here. Also, while creating custom exception gives the ability to also create your own specific, create your own as did here, but public double gets short for. We'll see what this method does in the short while. Basically, just what it's doing is providing the result of withdrawal amount minus balance. And again, this is another exception over here, invalid amount exception, which an argument of amount, and it calls the tradable class again, which takes in a message argument. As you all know, I didn't perform and do method a constructor overload here. I could have called the super constructors of I really don't have time for that right now. So this is a bank account class, which has a field of account holder and balance. The constructor, which takes in the argument of the account holder initial balance. You all know this already. So if I call the withdraw method here and I pass an argument here, basically this is just it's simulation of a bank application. These are bank applications that are built per se. You do it like this, and you go to J. As I was saying, it draw
Hi, Ife.
is
Ifeoluwa, can you hear me?
Yeah.
Sorry, your network is a bit shaky.
How many minutes?
Your network. Yes, we can hear you, but your network is a bit shaky at some point.
Hello, can you guys hear me now? Hello.
Yeah, it's better now. Thank you.
Draw method. If amount you pass as an argument is lesser than or greater than or equals to 0, it should throw this new valid amount exception. The exception class that we created over here, it should throw the exception. If the amount we want to withdraw is greater than the balance in our bank account, it should throw the new insufficient funds exceptions. Whereas if none of this is true, this should happen. Withdraw successful new balance, and the amount will be deducted from your balance per se. So basically, when you throw an exception and once this line hits, all other lines in this method are redundant. This will not run. It's basically, I don't want to really compare it to the return keyword, but it's basically how the return keyword is. If you have a return keyword over here, and this is true, once this return keyword runs, we know obviously that the method exits. So basically, that's what throw also is. And this is what I was talking about. Throw is the act of creating and throwing the exception to the runtime system. So this is the ability to throw exception explicitly. You as a developer wants to throw the exception. So, and please can you guys see him?
Yes.
Yes, we can.
Okay. So in the main class over here, I created a bank account object, as you can see here, passing John Smith and 500. Now, this is the try block, which I put in a try block minus 100. All these are just simulations. As we saw previously, if the amount is less than 100, this this exception class here will be created and exception object here will be created and be shown to the runtime system. So obviously we know that this is going to run. Now, if the amount I pass as argument is 800, I know in the initial balance we pass is 500. So now, if the amount is greater than the runtime system, so this should still run again. While this is just to catch anything bank related, which is obviously not going to run. This catch block is not going to run. That's what I meant. This catch block is not going to run because we're passing in an argument of amount 200, amount is greater than 0 and is less than the initial balance. So I just run all this. Like I said, this is the first simulation over here. The draw amount must be greater than 0, greater than 0, received minus 100. That is coming from this class. Over the next one was transaction. Where's my main class? Transaction field. I'm not withdraw 800 naira. Current balance is 500 naira. You are short by either get short or method. Where did I create that? Get short for. So it's showing how much you are short by when you want to withdraw. Let's say and catch anything bank related. Obviously, this is successful because it passes the condition. So that's basically how we can throw exception with the throw and throw. So throw is basically the method signaling to the caller that I'm capable of throwing an exception and must be ready to deal with it. And throw is just the act of creating and throwing an exception explicitly. Best practice. Always catch specific exceptions before catching broader exceptions. I showed this earlier. Always catch specific exceptions always before catching broader exceptions. Use custom exceptions only when standard Java exceptions don't clearly describe the problem. Only use custom exception when the standard exception provided by Java don't specifically define your problem. So don't just go around creating exception. And I also forgot to say, when you create custom exception, you must always name them with exception at the end, like I did over here. So that's just the normal naming convention. You can go against it, but that's just normal naming convention. Let's follow the best practices. Name exception clearly to reflect the error. Always name your exception clearly to reflect the error. As you all know, name things so that you make it easier for the next person to read. Avoid overusing exception. Don't use them for normal control flow. This is a good tip. Beginners always tend to, I say beginner, I'm a beginner. Beginners always tend to overuse exceptions after they've learned it. And one thing we have to remember is exceptions are also objects. I say they are stored, once they are created, they are stored in the heap memory. So we should not always go around creating and overriding exception just to we should not use them for the normal control flow of our application. Include helpful messages and if needed, underlying causes to aid exception. I really wish I had time to show chain exception so I could really explain this more. I do not have the time for that. So resources, use dev.java advanced exception handling by Alexander Obregon. Throws versus try catch by Alexander Obregon. So thank you everyone. I hope you all had a very good, beautiful intro into exception. Thank you.
Thank you very much, Ifeoluwa, for that awesome presentation. Thank you, thank you. If you have any questions, please you can signify by raising up your hand, drop your questions on the comments, or just raise up your hands and ask. And that means if Ifeoluwa did a wonderful job with the explanation. Thank you so much, Ifeoluwa, for that wonderful section. It was really detailed and very self-explanatory. Well done. Well, I want to once again welcome those that are joining us for the first time. On the chat, there's a link to all our different social media platforms. You can follow us on WhatsApp, on Instagram, join our group on WhatsApp so you don't miss out on sections like this. And you can also follow us on LinkedIn and all of that. Um, Nobody has any questions? All right, all right. I hope that after this section today, we'll be able to handle our exceptions better, know when to throw custom exceptions, and handle exceptions more gracefully. So thank you everyone for joining today's live. Handing over the mic to Gloria to pick it up from here. Hi, Gloria.
Hi, Rosemary. Good evening. Thank you, everyone. Thank you, Ifeoluwa. Thank you for that awesome presentation. So that will be all for tonight's section. So if there is any other information to reaching out to us on or before whatever section we are having, do have a wonderful night rest. Thank you, everyone. Okay, Ifeoluwa, I can ask your question.
Okay. Samuel, sorry, is there anything you wanted to say? Or is everything okay?
So why do you want to hear my voice?
I'll just
Well, that was a wonderful session. Thank you very much.
okay.
I don't know why you want to hear my voice.
I wanted to hear your praise,
That was
actually,
nice.
your praise. You've already praised me. I actually wanted to hear your praise. You already praised me. So
okay, let me praise. Okay, shout out to